Hi everyone, I'm Eloise and welcome back to our microlearning sprint here with Coding Kids. We're going to be talking about the last three of the 6 fundamental concepts of coding today. So we've already covered sequencing, branching and iteration. And today we're going to be looking at arithmetic, data storage and data inputs and data outputs. Now, I know that seems like a lot, but they're all interconnected. So arithmetic really easily ties into data storage, and data storage really easily becomes data inputs and outputs. So first of all, arithmetic. Well, crazy as it seems, we actually use maths operations a lot in coding. So things like plus, minus, multiplication, division, equality, less than, greater than, all those fun things. Now in Scratch, we'll actually find those coding blocks in the operations category. So that's these ones just here. They're light green colored coding blocks and they're really easy to identify. Now maths is really useful in coding because it allows us to process data. And that actually brings us perfectly onto the next concept already, which is data storage. Now, data storage is talking about the memories that computers have. They have really, really amazing memories. They're really good at storing data for a really long time, and in general, they're much better than human memories. Now, in coding, we use various types of data storage devices like variables and lists. And in Scratch, there are variables and list blocks that we can use, and that's these ones just here. Now, a variable stores one piece of data. So you can imagine a storage box that can only store one item at a time. We can change what a variable stores, but it will only have that one item at a time. So for example, in Scratch, when we build a computer game, we may want to store the player's score, which is a number. We can store this number in a variable, and then we can give that variable a name. And if we're keeping score, we might choose to name the variable score. Now, a variable can only store one piece of data at a time, but a list can store a number of pieces of data. We can add multiple items to the list, and we can actually remove items from the list as well. So I have here a more advanced version of that maze game that we were looking at a few days ago now. So you can actually collect items. Oops. There we go. You can actually collect items, and with each item that you collect, you earn a point. Your score is then stored in the variable called score. Now, I'll try and find a little picture of this code to show you. Yeah, so you can see in this code that we set the variable score to 0 at the very beginning of the game. That's this block just here. And then if score equals 4, you win. So we use equality, so in this case, arithmetic and the equal sign block, which is this one just here, to determine when the win condition is met. And now, data inputs and outputs. So the data that's stored in the variable score, that's going to change over time. It'll start at 0 at the very beginning of the game, which we looked at just then, and then it'll increase every time the right condition is met. So in this case, it'll be when the player collects the correct items, it'll earn 1 point per item. We add 1 to the current score to calculate the new score, which we can find in this block just here. You can see that one just there. That says change score by 1. And then, like we saw in the previous block here, when the score equals 4, the game will display the text "you win," and an applause sound effect will be played. Then the output is text display and sound effects. So other examples of various kinds of inputs might be things like graphic files, sound files, pressing keys on a keyboard, or even using a mouse to give user input. And then other kinds of outputs could be things like displaying on the screen, printing something, playing some sound, or even running a motor if you're working with like a little robot or something. So we'll try and think of this now in the example of the baking the cake analogy that we've been using for a little while now. So first of all, arithmetic. So just again, talking about really basic math stuff right now. So let's say that we have a 500 gram block of butter, but we only need 125 grams in this actual cake. So we need to try and think of how can we get to 125 grams? Do we have to weigh it? Anything like that? How many blocks of butter would we need if we wanted to bake 3 cakes instead of just 1? And then let's say we wanted to slice the cake into 8 equal pieces. What angle could we need to make the tip of each cake slice? Those sorts of things. So basically just maths. And then with data storage, so with baking a cake, it's a bit strange to think about, but our ingredients are actually our data. So they all come in some form of packaging. So in this case, eggs will come in a carton, flour comes in a paper bag, butter comes in wax paper, and that form of packaging is a form of data storage. And then as we start making our cake, we're going to start putting those ingredients or our data into other kinds of storage containers. So we might even mix them together, which would be a form of data processing, which we'll talk about in a moment. So we might put all of our ingredients into a mixing bowl, and then we'll mix all the ingredients together, and the mixing bowl has been the data storage, but now we want to put it into a baking tin. So the baking tin becomes the data storage. So it's just like a location where we can keep all of our data bit by bit as we move along through our code. And every single storage container has a specific purpose. So the mixing bowl stores the ingredients while they're being mixed together. The baking tin holds the mix when it's actually being baked in the oven. And then another kind of data storage location could even just be the plate, which holds the slice of cake before it's being served to the users. Now, finally, data inputs and data outputs, again, in the context of baking this cake. So our data inputs, as we just said before, our ingredients, obviously we need those to bake the cake. And then some other things that we would need to put into the process of making the cake to actually get the right output would be things like utensils and equipment, and even ourselves, because you need to have a person to actually mix everything together and follow the recipe. That would be for labor purposes. And then the data processing would be the actual process of following the recipe. So mixing everything together, measuring things out, putting it in the putting the baking tin into the oven, cooking it, bringing it out, decorating it, slicing it up, and finally serving it on a plate. And then our data output would be when we actually have a slice of cake on a plate served to someone else. So the data output, the output data, which in this case is the slice of cake, is then served to the user. And that's honestly all it is. There you have it. So the final three of the 6 fundamental concepts of coding. So those were arithmetic, data storage, and data inputs and outputs. And just a reminder, our first 3 that we covered already were sequencing, branching, and iteration. Now remember, you can click on the link below if you want to do the 1 to 2 minute mini quiz, and if you do all 10 quizzes, then you'll receive your certificate for an hour of PD. Now tomorrow I'm going to be going into an introduction to Scratch. I look forward to seeing you all tomorrow. Bye, this is Eloise, signing off.